Okay, welcome back to MechSolids FEA tutorials. In this one, we're going to be going over cantilever beam torsion and how to set that up. Okay, so I've already made the part this time. So this is a solid aluminum bar connected to a aluminum pipe that is hollow, as you can see. Okay, so just like before, we're going to go to simulation and hit new study and call this one beam torsion. Okay, just like before, we're gonna select the whole part and then hit apply material. This is just gonna be 6061 aluminum. Cool. Next, we're gonna set up the fixed geometry on this end of the pipe, or the beam, I should say. Okay. Next, this is the main part we're looking at. So it's how to apply torque to your Solidworks part. So we're going to go torque. Okay, so there's two things here. The first thing you're going to click is the face or like plane that this torsion is happening in. So we're going to have a force at this point here. Sorry, a torsion at a moment at this point here. Okay, so we're going to click this face. And then this pink box is for the direction that the moment will go about. You can see I can click either of these circles, and it's just saying that the forces kind of go in a circle around it like that. Okay, I'm gonna set that to say 1,000 pounds. Yep, and of course you should tailor these values to the problem you're dealing with. Okay, next I'm gonna add another torque, but to this face instead this time. And same thing, just hit the direction, and I'm gonna reverse the direction this time. So these torques go in opposite directions, and give this a value of, say, 500 pounds. Pound inches, I should say. Okay, so last time we represented this beam by like right-clicking it and saying treat as beam. This time, we're gonna create a mesh of the model. So the way you do that is you go to the caret under run the study and hit create mesh. So you can drag this little cursor between coarse and fine, and that will change like basically the amount and size of the triangles the mesh is made out of. So you can see if I create a coarse mesh, we've got pretty big triangles here. However, if I create a finer mesh, you can see we have much smaller triangles. So the finer the mesh, the more accurate your values are going to be. However, the finer it is, especially with more complicated parts, the longer the runtime will be. So generally somewhere in the middle works perfectly fine. So I generally like leave it like around here. Okay, now that we've created our mesh, we can hit run study. Okay, looks pretty weird, but of course this is deformed to show you what is happening. So yeah, just like before, you can sort through all your different stresses. If you want to look at something other than the von Mises stress, you can right-click the plot and then go to the stress component, and you've got all these different things that you can look at. Like some of the ones you'll probably use the most are the normal stresses in each of your X, Y, and Z directions, as well as your principal stresses here. Okay, you can also double click here to go to your displacement and strain. And something I like to do for both of those is, so I just double click that to get to this part, One, important, set your units. Next, I always like to hit show min and max and just make sure that those things make sense. So it's saying the min stress is somewhere in the middle of this aluminum tube. That makes sense. And it's in this one. And the max stress is at the start of the uh, smaller pipe. And that makes sense because this is the area where the two torques are kind of going against each other. So yeah, that's how you set up a cantilever torsion problem in SolidWorks.